With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, uniform rod AB is hinged at the end A in a horizontal position as shown in the figure. The hinge is frictionless, that is, it does not exert any friction force on the rod. The other end of the rod is connected to a block through a massless string. As shown, the pulley is smooth and massless. Masses of the block and the rod are same and are equal to m. So we have to find out then just after release of block from this position, the magnitude of reaction exerted by hinge on the rod is. Okay, so we have to find out the reaction which is exerted by hinge on the rod is. As you can see in the diagram, there is a rod having mass m and length l. At A end it is connected with the hinge, and at B end it is connected with a pulley, and that pulley is connected to a block which is having the same mass as rod, that is m. Okay, so now we assume that this mass of block m is moving with the acceleration a in downward direction. Okay, so suppose this mass is moving in downward direction with acceleration a, and this rod is moving with alpha, angular acceleration alpha, in this direction. Okay, now I'm going to draw free body diagram of block m as well as this rod. Okay, now, but the first one thing which is in question, they are saying that the pulley is smooth and massless, that means the spring is ideal, and for ideal spring the value of a is equals to alpha l. The acceleration is equals to alpha, which is angular acceleration, into length for ideal string. Okay, now I'm going to draw free body diagram of block m, and for rod, this is block m which is moving in direction in vertically downward with acceleration a. Now the weight of this block is acting downward, that is mg, and because of this weight there is a tension in the thread. So for this block I'm going the force, I'm write a force equation by Newton's law. So I can write mg minus t, that is equals to ma, and from here I can also write a equals to g minus t upon m. Suppose this is my equation first and this equation is for block. Similarly, I am going to draw a diagram for rod also. The rod is, as you can see in the diagram, the rod is this, which is having mass m and length l. So at center of mass means this length is l by 2. From center of mass the weight is acting downward, that is mg. Okay, and there is a tension in the string which is connected to this. There is a tension, that is T. So I'm going to write a torque equation for this rod, and we know that torque is equals to I alpha, and torque is equals to force into perpendicular distance. So as you can see on rod there are two forces acting. First is tension and second is mg, and this rod is moving with angular acceleration alpha. So I can write the torque equation, that is equals to force, first force is tension, into perpendicular distance is length, and second force is mg, that is weight, and length is l by 2. Force into perpendicular length, this is torque, and it is equals to I alpha. I is the moment of inertia, and moment of inertia of rod when it is suspended about the end, it is given by ml square upon 3 alpha. This is the torque equation for rod, and I can also write this equation as alpha l equals to 3t upon m minus 3g by 2. Suppose this is my equation second, and this equation is for rod. Now as you can see that first for block equation is a equals to something, and for rod equation is alpha l equals to something, and we already know that a equals to alpha l because string is ideal. So I can write that equation 1 is equals to equation 2. So I can write equation 1, that is a equals to g minus t upon m, and that is equals to alpha l, which is equals to 3t upon m minus 3g by 2. Simplifying this equation, g plus 3g by 2, that is equals to 3t upon m plus t upon m, that is 4t upon m. Okay, so it is 5g by 2, that is equals to 4t by m. So from here the value of tension in string T is coming out to be 5 mg upon 8. This is the value of tension in string. Now if I put the value of T in equation second is alpha L equals to 3t by m minus 3g by 2. If I put the equation, the value of T in this, alpha L equals to 3 upon m. The value of T is 5 mg upon 8 minus 3g by 2. Simplifying this equation, we will have alpha L equals to 15g minus 12g upon 8. That means this is equals to 15 minus 12, it is 3g by 8. Okay, so from here the value of alpha is equals to 3g by 8 L. This is the angular acceleration of rod, that is equals to 3g by 8 L. Okay, now they are asking about the reaction that is exerted by this hinge in rod. So this hinge is exerted reaction in two direction. First in horizontal direction, suppose in horizontal direction the reaction is Rx, and in vertical direction it is Ry. Okay, the hinge is basically exerted two reaction. Okay, reaction in two direction, two reaction in two direction. First in horizontal direction and second in vertical direction. Okay, in horizontal direction there is no force, as you can see in the diagram. In horizontal direction there is no force, that means in this direction there is no reaction. So we have to basically find out the vertical reaction, that is Ry. So I can write the equation for vertical direction. In vertical direction the tension is acting, this is T, this is also T, this is mg, and at the center of mass this is also mg. So basically in vertically upward direction or in y direction there are two forces. First is tension, second is mg, and third is r by 1, 2 and 3. There are three forces which is acting in vertically upward and downward direction, that is the y direction. Either it is positive y or negative y. So the equation can be written as Ry, that is vertically upward, plus tension, that is also vertically upward, minus mg, because mg is acting in downward direction, so it is a minus sign, and that is equals to ma, force equals to ma, and this a is basically center of mass, acceleration of center of mass, and that is equals to acceleration equals to alpha L, and for center of mass it is L by 2. So putting the equation, I can write Ry plus T minus mg, that is equals to m alpha L by 2. Okay, now I'm going to put the value of alpha, which I already calculated. Value of alpha is 3g by 8L. So after putting the value of alpha, Ry plus T minus mg equals to m, value of alpha, that is 3g by 8L into L by 2. Simplifying this equation, we will have Ry, and we already calculated the value of tension also. So I am going to put the value of tension, that is equals to Ry plus 5 mg by 8. I already calculated the value of tension to 5 mg by 8 minus mg, and this is equals to 3 mg by 16, because L cancel out, so it is 3 mg by 16. Now simplifying this equation, I will have Ry, that is equals to Ry, that is equals to 19 mg upon 16 minus 5 mg by 8. Further simplifying this, the value of Ry is coming out to be 9 mg by 16. This is the reaction which is exerted by the hinge on rod in y direction or in vertical direction. This we have to calculate it. So let's check the options. In the option, the third option, which is 9 mg upon 16, is the correct option. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.